Hi, welcome to Succeed e-learning app. The topic for discussion is coordinate geometry. What is coordinate geometry? Coordinate geometry, like the name suggests, is a study of coordinate points. It helps us to study geometry using algebra and understand algebra using geometry. Now, let us quickly recall what you have learnt in your previous classes. Like you already know, to locate the position of point on a plane, we need a pair of axes. Now, let us look at a plane. The horizontal line that you see is called x-axis, while the vertical line that you see is called a y-axis. And the intersection between the x and y axes is called as origin, denoted by O. The distance of a point from its y-axis is called its x-coordinate, while the distance of a point from its x-axis is called its y-coordinate. Now, let us see what you will learn in this chapter. First, to find the distance between two points whose coordinates are given. Second, to find the area of a triangle whose coordinates are given. Third, to find the coordinates of a point which divides a line segment in any given ratio. Now, I will teach you distance formula. Distance formula will help us to identify the distance between two points whose coordinates are given. Let us take an example. There are two towns, town A and town B. Town B is towards 36 kilometers east and 15 kilometers further north from town A. How will you measure the distance between town A and town B without having actually measuring it? You can do so using Pythagoras theorem. The distance will be square root of 36 square plus 15 square, which will work out to 39. Let us take another example. The coordinates of points P 4, 6 and Q 6, 8 is given. How will you identify the distance between P and Q? Let us draw a perpendicular line from P and Q to x-axis to form PQ and RS. Let us also draw a perpendicular line to QS from point P in this manner, which meets QS at point T. Now, we will learn the distance between P and Q in 3 steps. Step 1. PT is equal to RS, which is equal to OS minus OR. So, PT will be 6 minus 4 is equal to 2. Step 2. We will find QT, which is nothing but SQ minus ST, which is 8 minus 6 equals 2. Step 3. Now, the distance between PQ can be arrived using Pythagoras theorem. AC square is equal to AB square plus BC square. Here, PQ square is equal to PT square plus QT square. So, PQ will be square root of 2 square plus 2 square, which is square root of 8, nothing but 2 square root of 2. In the same example, let us denote the coordinates of point P and Q as P x1 y1 and Q x2 y2 instead of P 4, 6 and Q 6, 8. In the step 1, we have done 6 minus 4, which is nothing but x2 minus x1. In the step 2, we have done 8 minus 6, which is nothing but y2 minus y1. In the step 3, we have applied Pythagoras theorem, so the distance will be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, which is known as distance formula. I hope you can apply this distance formula to find distance between any two points whose coordinates are given. Let us now move on to section formula. Section formula will help us to identify coordinates of a point which divides a line segment in any given ratio. Now, let us move on to area of a triangle. In your previous classes, you have learnt to identify the area of a triangle whose base and height are given. You might remember using the formula area of a triangle is equal to 1 by 2 into base into height. In this topic, you will now learn to find the area of a triangle whose three coordinates are given. A telephone company wants to position a tower at point P in between A and B in such a manner that the distance of the tower from B is 2 times its distance from A. If we take A as origin and it is given that the coordinates of point B is 36, 15, how do we identify the coordinates of point P? To do this, let us draw perpendicular from P and B to x-axis, which meets x-axis at D and E respectively. Also, draw PC perpendicular to BE. Basis the similarity criteria studied in the previous chapter triangles, we can conclude that the two triangles, that is triangle POD and triangle BPC, are similar, which implies that all the three sides of the triangle are in the ratio 1:2. Therefore, OD by PC is equal to PD by BC, which is equal to OP by PB, which is equal to 1 by 2. OD by PC is nothing but x divided by 36 minus x. PD divided by BC is equal to y divided by 15 minus y. By solving the above equation will give us x equals 12 and y equals 5, which meets the condition that AP is to PB is equal to 1:2. You can recheck the calculation using the distance formula learnt in the previous section and reconfirm that AP is to PB is 1:2. Now, let us generalize this by way of a formula. Consider 3 points A, x1, y1, P, x, y and B, x2, y2. Here point P divides line segment AB in the ratio of M1 is to M2. Therefore, M1 divided by M2 is equal to x minus x1 divided by x2 minus x is equal to y minus y1 divided by y2 minus y. By further simplifying the equation for x and y, we get x is equal to m1 x2 plus m2 x1 divided by m1 plus m2, and y equals m1 y2 plus m2 y1 divided by m1 plus m2. Consider the triangle ABC with respective coordinates A x1 y1, B x2 y2 and C x3 y3. Now let us draw perpendicular lines AP, BQ and CR from points A, B and C to the x-axis respectively. Now we have ABQP, APRC and BQRC, which are all trapezia. From the diagram, it is clear that area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC. Area of a trapezium is equal to 1 by 2 into sum of parallel sides into the distance between them. By substituting the formula, area of trapezium ABQP is equal to 1 by 2 into y2 plus y1 into x1 minus x2. Area of trapezium APRC is equal to 1 by 2 into y1 plus y3 into x3 minus x1. Area of trapezium BQRC is equal to 1 by 2 into y2 plus y3 into x3 minus x2. Therefore, we can say area of triangle ABC is equal to 1 by 2 into y2 plus y1 into x1 minus x2 plus 1 by 2 into y1 plus y3 into x3 minus x1 minus 1 by 2 into y2 plus y3 into x3 minus x2. By further simplifying the equation, area of a triangle ABC will be 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, which is the formula for finding area of a triangle. I hope the three formulae that you learnt in this chapter you will be able to apply and arrive at a desired objective. Thank you for watching us. For more videos, please watch Succeed e-Learning app.